All right.
Recording in progress.
Hello, everyone, and welcome back. We are continuing on with the MCT4C course. This is lesson 9 of Unit 2. We're finishing up the question from last time before we move on to today. And so we were looking to apply the quadratic formula. Namely, if we had something like, say, 2x squared minus 4x plus 1, we know that x will be equal to negative b plus or minus the square root of b squared minus 4ac over top of 2a. Now, in this case, we were told that a will be 2, b will be negative 4, and c will be 1. So consequently, we will end up with x is equal to negative 4 plus or minus the square root of negative b to the power of 2 minus 4 times 2 times 1 divided by 2 times 2. And so if we're cleaning this up, negative 4 will be positive 4 plus or minus the square root of negative 4 to the power of 2 is 16. Negative 4 times 2 times 1 will be minus 8 all over 4. So x will be equal to 4 plus or minus the square root of 16 minus 8 is 8 over 4. So therefore, our solutions will be x is equal to 4 plus the square root of 8 over 4, and x will be equal to 4 minus the square root of 8 over 4. And so from here, you can type this into your calculator to go ahead and determine the answers. But for the most part, we're quite happy with these uh, radical answers as a solution. Okay, so let's continue on with today's lesson. And so again, we are on MCT4C. This is Unit 2 again. We're still on Lesson 9, but this is the second part, 2 of 2. And so in this lesson, we're going to be having a look at solving polynomial equations via factoring. And in general, we should be able to factor and solve polynomial equations. We're going to be using a combination of either long division or the method of undetermined coefficients. And the vehicle to make these happen we'll be using is just the factor theorem. So in general, we'll be able to factor and solve these. So last time we had to look at to see whether we had to use either a combination of common factoring or factoring by grouping in order to solve those. And you should always check to make sure you are able to solve those before continuing on, just to see if there's any good method for continuing on. However, sometimes when we want to solve for these things, we can't use those techniques. And in fact, we're going to need to just end up using the factor theorem to solve this. And so what do we have here? So we're going to solve for x, and we will need to use the factor theorem and can use either long division or the method of undetermined coefficients to figure this out. And so if you have x cubed plus 9x squared plus 13x plus 5, we should be, when we're looking at this, we need to use the integral zero theorem. And we can have a look and say, okay, well, we need to find factors that will multiply to make 5. So the factors we should check will be plus or minus 1 and plus or minus 5. And so I think negative 1 looks like a pretty good candidate here. In fact, we go. If we type in here negative 1 to the power of 3 plus 9 times negative 1 squared plus 13 times negative 1 plus 5, we can see this is equal to 0. So we can say since, and we can call this f of x, f of negative 1 is equal to 0, we can say x plus 1 is a factor. And so if we want to test to see how this works, using long division, we would take our x plus 1, and we want to see how many times it will be divided into the cubic polynomial x to the power of 3 plus 9x squared plus 13x plus 5. The reason why I say that we need to use long division here is because if you notice at the start, we can't do any factoring by grouping, because if you look at the coefficients on the x cubed and the x squared, we have a ratio of 9. But then if we have a look at the 13x and the 5, we can see the ratio appears to be 5/13. So there's no group factoring to be done there. And so we ask ourselves on this line, how many times does x go into x cubed? It goes in x squared times. And so we'll put an x squared up here. And on this line, we will write x squared multiplied by x plus 1. Okay. And so we can write this down. X squared times x is x to the power of 3. X squared times positive 1 is a x squared. And so if we subtract this, x to the power of 3 minus x to the power of 3 is 0. 9x squared minus x squared will be 8x squared. Bring down the 13x. So at this point, we ask ourselves, how many times does x go into 8x squared? So if we take our 8x squared divided by x, we end up with 8x. So up here, we will write our plus 8x and 8x squared, 8x. And then on this line, we'll write 8x multiplied by x plus 1. And so that's going to give us 8x squared plus 8x. And we'll minus this off. So 8x squared minus 8x squared is 0. 13x minus 5x, minus 8x is 5x. Bring down the 5. So we end up with 5x plus 5. And then lastly, we see, okay, well, how many times does x go into 5x? Well, it goes in 5 times. So we go plus 5. And so on this line, we will have 5 times x plus 1. And when you subtract off these quantities, you get 0. And so we know that x cubed plus 9x squared plus 13x plus 5 is equal to x squared plus 8x plus 5 times x plus 1. Okay, so that's your first step there. Now, you could have also gotten this step using the method of undetermined coefficients. So namely, we knew that x plus 1 happened to be a factor. And so we know that this would be equal to x plus 1 times some ax squared plus bx plus c. And so if we were to multiply these things out, x times ax squared would be ax cubed. X times bx would be bx squared. X times c would be just x times c. And then we have 1 times that quantity. So we can add on a ax squared plus bx plus c. So the method of undetermined coefficients says that we can equate the variable and constant terms to each other. And so immediately you should be having a look at this x cubed term, and there's only other one term on the right. So we can see that there's an ax cubed on the right side. So this means that for one of our equations, x cubed must be equal to ax cubed. So if x cubed is equal to ax cubed, that means a has to be 1. And by a similar token, if I have a look at, say, my second equation, there's only a constant term of 5 on the right, and there's only a c on the right side. So then I know that 5 is equal to c. So we already know for this polynomial, a is equal to 1, and c is equal to 5. So for the b term, we can either get that from analyzing either the x squared terms or by analyzing the x terms. Either will not matter. So let's choose, say, the 9x squared term. And so for our third equation, we're going to end up with, say, 9x squared is equal to bx squared plus ax squared. But we already knew a was supposed to be equal to 1. So in reality, we have 9 is equal to b plus a. So 9 is equal to b plus 1, which means b is equal to 8. So therefore, we know that this factors to x plus 1 times x squared plus 8x plus 5. Okay, because we were able to determine quickly that a was 1, c was 5, and also that b had to be 8, which is what we had up here. And so you should be familiar with either technique in order to solve this. The usefulness of this is that you're able to, like, we can quickly tell, depending on the situation, sometimes long division might be faster. Sometimes the method of undetermined coefficients might be more efficient. Just depends on what you would like. And so now we have to factor this x squared plus 8x plus 5. And so the main problem I'm running into is that I don't know of two numbers such that they multiply to equal 5, but then add to make equal 8. So we need to use the quadratic formula, which said that x was equal to negative b plus or minus the square root of b squared minus 4ac over top of 2a. And so here we can say x is equal to, now a is equal to 1, b is equal to 8, and c is equal to 5. So x will be equal to negative 8 plus or minus the square root of b squared. So this will be 8 squared minus 4 times 1 times c over top of 2 times 1. So x will be equal to negative 8 plus or minus. So under the bracket there, we've got 8 squared minus 20. So that's going to be negative 8 plus or minus the square root of 44 over top of 2. And so we can see that therefore x will be equal to negative 8 plus the square root of 44 over 2, and x will be equal to negative 8 minus the square root of 44 over 2. And so on our calculator, if we were to type in negative 8 plus the square root of 44 over 2, we get x is equal to about negative 0.69, and x is equal to negative 7.32. So I just typed that into my calculator, negative 8 plus the square root of 44 over 2 and negative 8 minus the square root of 44 over 2. And combined with our previous solution, which we could see x was equal to 1, therefore the solutions are x is equal to negative 0.69, negative 1, and negative 7.32. And so sometimes when you factor these quadratics, you'll end up needing to use the quadratic formula. Sometimes you're going to end up with getting a whole solutions or integer solutions, I should say. And we just kind of go with it from there on a case-by-case basis. Okay, let's continue on. So we're going to solve the following. We've got here x cubed plus 3x squared minus 10x minus 24 is equal to 0. And so we just need to solve using any method. So we need to check factors of negative 24. So these values could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, and plus or minus 24. It's probably not 24 because the coefficients seem quite small in the middle. And so let's start off by testing f of 1. So in our equation, we're going to type in 1 to the power of 3 plus 3 times 1 squared minus 10 times 1 minus 24. Okay, so f of 1 equals negative 30. That's no good. What about f of negative 1? Well, we tried typing in a negative 1 here, and we're going to get negative 12. So that one doesn't appear to work. Let's try f of negative 2. Okay. F of 2 is equal to negative 0. So then we can say that x plus 2 is a factor. Okay, so we're going to use some method to go ahead and factor this. So let's use undetermined coefficients. So since I believe we have the space for it. And so we know that this was going to factor to x plus 2 times ax squared plus bx plus c. And as a little shortcut here, we know or can figure out quite quickly that from inspection, x times ax squared has to give us x cubed. And the only way that this will make sense is if a is equal to 1. And by a similar token, we can multiply the 2 by the c, and that has to equal negative 24. So 2 times c equals negative 24, which means c is equal to negative 12. Which means that when we go ahead and multiply this out, it's actually going to be x plus 2 times x squared plus bx minus 12. So we can just skip some steps and immediately and see this is the case. Okay, let's go ahead and multiply this out now. X times x squared is x cubed. X times bx is bx squared. X times negative 12 is negative 12x. 2 times x squared is 2x squared. 2 times bx is 2bx. And 2 times negative 12 is negative 24. Okay. Now from here, we can go ahead and equate our coefficients. So let's have a look at this 3x squared, this bx squared, and this 2x squared. And we can see that 3x squared has to be equal to bx squared plus 2x squared, otherwise known as 3 has to be equal to b plus 2, so b equals 1. So then we can say, therefore, x cubed plus 3x squared minus 10x minus 24 is equal to x plus 2 times x squared plus x minus 12. And so from here, we know we can have a look at this, x squared plus x minus 12. And we need to have two numbers that multiply to make negative 12 and add to make 1. Those numbers are going to be 4 and negative 3. And so we end up with x plus 2 multiplied by x plus 4 times x minus 3. And this all has to now be equal to 0. So here, therefore, we can conclude x must be equal to negative 2, negative 4, and 3 as our solutions. So we use the factor theorem to help us get started. Then we're able to just factor this using the method of undetermined coefficients. And then from here, we're able to determine the values had to be negative 2, negative 4, and 3. Okay, looks good. So let's continue on. For letter B, we have x cubed plus x minus 10. I automatically want to be using long division to figure this out, just as a nice little point of review. And here, the factors we should be checking are factors of negative 10, which are going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. I notice that we are missing since we're missing an x squared term, chances are it's probably not going to be one of the 10s. I'm going to start with the 1 or the 2 first. I'm going to start with f of negative 2 because of the coefficients. So here, f of negative 2 is going to be equal to 0. So if I take negative 2 cubed plus, in brackets, negative 2 minus 10, negative 2 minus 10. Ooh. 2. Oh, that didn't work. Oh, so negative 2 is equal to, oh, Desmos scientific calculator. That ended up equaling negative 20. And if I try f of 2, that's going to be equal to 0. Okay. So if I type in 2 cubed plus 2 minus 10, yeah, that equals 0. Okay. So then we know x minus 2 is a factor. So I said I wanted to use long division here just because I didn't have an x squared term and I thought it'd be a nice review. So we're going to take x minus 2, and we have plenty of space here. And we're going to divide it into x cubed. Now remember, when we're doing this, we need a placeholder 0. So we need a plus 0x squared plus x minus 10 term. And so we go through the algorithm. Okay, so how many times does x go into x cubed? It goes in x squared times. So on this line, we're going to write x squared times x minus 2. So that's going to be x cubed minus 2x squared. Minusing them off, we're going to end up getting 2x squared. Bring down the x. How many times does x go into 2x? How many times does x go into 2x squared? It goes in 2x times. So on this line, we're going to write 2x times x minus 2. So 2x times x is 2x squared. 2x times negative 2 is negative 4x. We subtract this off. 2x squared minus 2x squared is 0. X minus 4x is 5x. Bring down the minus 10. How many times does x go into 5x? it goes in 5 times. So on this line, 5 times x minus 2, that's going to give us 5x minus 10, which is going to give us 0. Okay, so therefore, we know that this will be, we're trying to now solve, 0 is equal to x minus 2 times x squared plus 2x plus 5. Now, a very reasonable question you might be asking yourselves is, hey, in a previous lesson, didn't we just use the factor theorem just to kind of find all the solutions? And we did. And the question then becomes is, can't we just use the factor theorem to find all of the solutions? We could. That would work if all of the solutions were guaranteed to be integer solutions. However, when you're solving these, like for example, in example 2a, you could have used the factor theorem to solve this because you would eventually found that -2, -4, and 3 were all solutions to this. However, in the case of letter B, we now have to factor x squared plus 2x plus 5, but I cannot think of numbers that multiply to make 5 and add to make 2. So we have to use the quadratic formula there. And so we have x is equal to -2 plus or minus the square root of b squared. So this will be 2 squared minus 4 times a times 5 over top of 2 times 1. So x will be equal to -2 plus or minus. So this is 4 minus 20, which is -16 over 2. So here, this is a problem because if you try to take the square root of a negative number, it's undefined in real numbers. And so here we say that this will have no real solutions. So this quadratic portion doesn't cross the x-axis at all. And therefore, the only solution is x is equal to 2. And we say no real solutions because complex numbers, which is a topic we will not study in this course, do exist. So we don't like to say no solutions. We like to say that there is no real solutions, except x equals 2 happens to be 1. So if you were to rely upon just the factor theorem in order to try this out, you would end up trying out plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. You'd find one of the solutions, but then you might miss the other one. And in this case, there is no real solution, but we could have easily could have used the quadratic formula and found 2 solutions. So that's why we want to try to use we want to try to factor it first because it oftentimes will be quicker, assuming that there are answers to find. Okay, let's continue on. And I guess you should say at this point, this is the only solution. Okay, so we have x here, letter D. X to the power of 4 minus 4x cubed minus 7x squared plus 10x. So automatically here, I notice a common factor of x. They all contain an x value. So I can factor that out. And so we're going to have x outside of x to the power of 3 minus 4x squared minus 7x plus 10 must be equal to 0. Now, again, we have to apply the integer 0 theorem. So we're trying to factor now this portion. And so we know 10 will be some combination of plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So this is a quartic, which means it can have up to 4 solutions. We know it has at least one. X equals 0 is a solution. So if I have x cubed minus 4x squared minus 7x plus 10, looks like x equals 1 is going to be a solution, but we should test it out because I was wrong last time and it's possible I can be wrong again. So we have x to the power of 3, so it's going to be 1 to the power of 3 minus 4 times 1 to the power of 2 minus 7 times 1 plus 10. Okay, so then we know, so we can say f of 1 is equal to 0. So that means we know x minus 1 is a factor. So we can use our favorite method to factor this at this point. I do like the method of undetermined coefficients. So let's try x cubed minus 4x squared minus 7x plus 10 is equal to x minus 1 times ax squared plus bx plus c. So because of the logic we said earlier, if we have a look at the x cubed term, we're going to have the situation where x to the power of 3 is equal to ax cubed, which means a is equal to 1. And we're going to have the situation here where ten is equal to negative c. So c must be equal to negative 10. And so when we factor this out, we're now dealing with x minus 1 times x squared plus bx minus 10 is equal to that above information. So x times x is x cubed, x times bx is bx squared, x times negative 10 is negative 10x, and then it's negative 1 times x squared is negative x squared, negative 1 times bx is negative bx, negative 1 times negative 10 is positive 10, and this has to equal that stuff from above. And so at this point, we can equate the relevant coefficients. So we should notice here that we have let's have a look at this negative 4 here. Negative 4 will be equal to bx squared minus x squared. So for our equation 3, we know that negative 4x squared is equal to bx squared minus x squared, which means negative 4 is equal to b minus 1. So b is equal to negative 3. So all that's to say that this thing is now going to be equal to x multiplied by x minus 1 times the quadratic, which we now know is going to be x squared minus 3x minus 10. Okay, so remember, we had this x came from here. That came from the start because we had to common factor. We have this x minus 1 term because we use the method of undetermined coefficients to determine that the resulting quadratic must be this. And now we can factor this as a normal quadratic. So we need to figure out two numbers that multiply to make negative 10 and add to make negative 5. Perhaps I can write this a bit better. So they have to multiply to equal negative 10 and add to make negative 3. Those numbers are going to be negative 5 and 2. So this is going to be equal to x times x minus 1 times x minus 5 times x plus 2. So therefore, x will be equal to negative 2, 0, 1, and 5. So this could have also been a question where you could have solved this using the factor theorem, and that would have worked. But we have 4 solutions, so-called, actually, as I line them up, 2015. So there you go. Okay, so here we used the factor theorem and the method of undetermined coefficients into simple quadratic factoring. So that's why I saved this particular part of the lesson till last, because if you were to try to figure this out without these methods, like this would be pretty hard to solve without these tools in hand. Okay, so it's a lot of steps for us to solve this, but again, all completely reasonable as long as we know the method to solve these things. Okay. Letter D, we have x to the power of 3 minus 6x squared plus 11x minus x. I can see that there's no common factoring. Also, if I look at factoring by grouping, that can't really be done because we have 6 and 1 and then 6 and 11, so that's not going to work. And so we have to check the factors of -6. So -6 has as factors plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So just by inspection, looks like 1 is going to work. So if I take 1 to the power of 3 minus 6 times 1 squared plus 11 times 1 minus 6, I get 0. So we can see f of 1 is equal to 0. So we know x minus 1 is a factor. So from here, we can choose our favorite method to factor this. Let's try out long division. So if I take x minus 1, and divide it into x to the power of 3 minus 6x squared plus 11x minus 6. X goes into x cubed, x squared times. So on this line, I can take x squared times x minus 1. And if I do that, I end up getting x to the power of 3 minus x squared. Subtracting these off, x cubed minus x cubed is 0. -6 minus negative x squared is going to be negative 5x squared. Bring down the 11x. How many times does x go into negative 5x squared? It goes in negative 5x times. So on this line, I'll write negative 5x times x minus 1. So negative 5x times x is going to be negative 5x squared. Negative 5x times negative 1 will be positive 5x. Subtracting these off, negative 5x squared minus negative 5x squared is 0. 11 minus 5 of the x variety will be 6x. Bring down this minus 6. Then we ask ourselves, x times what gives us, or sorry, how many times does x go into 6x? It goes in 6 times. So on this line, I can write 6 multiplied by x minus 1. And so that's going to give us 6x minus 6, which is a remainder of 0. So we know that this thing will now factor to x minus 1 times x to the power of 2 minus 5x plus 6. So we can now look at this portion. We need to now ask ourselves the question, what multiplies to equal negative 5, and what two numbers add to give you negative 5, but multiply to give you positive 6? So again, given x squared minus 5x is equal to 6, what two numbers multiply to give you 6? What two numbers add to give you negative 5? Those numbers are going to be negative 2 and positive at negative 2 and negative 3. So this will factor to become x minus 1 times x minus 2 times x minus 3. And we're solving where this is equal to 0. So therefore, x is equal to 1, 2, and 3. So we could have just used the factor theorem for this one. And pretty much like one of the most common ones that we tend to use in most courses is you'll see something like this. Like you'll see the coefficients 1, 6, 11, and 6 and be like, oh, that's probably, it has its answers there, 1, 2, and 3 of some kind, probably. And indeed, this is the case. Okay. So lots of methods to figure this out. We can use undetermined coefficients, the factor theorem, but again, we're looking to solve this, and solve means what values of x cause this polynomial to equal 0. And so just as a recall that those 1, 2, and 3 correspond to the x-intercepts are 1, 2, and 3. Okay. Well, let's continue on. Letter E, we've got negative x cubed plus x minus x squared plus 1. And we actually can factor by grouping. So if you notice here, oh, actually, what I should first do is rearrange these. So we're going to move the negative x squared over. So it'll be negative x cubed minus x squared plus x plus 1. So we can see that this negative 1 is 1 times as big as negative 1, and then that this 1 is 1 times as large as 1. So we can factor these in pairs. So what's common to negative x cubed and negative x squared? That'll be negative 1 outside of, sorry, what's common to negative x cubed minus x squared will be negative x squared. And what will be left over is x plus 1. From x plus 1, we can factor just a regular 1 for x plus 1, and this will be equal to 0. And so we can binomial factor, and so we're going to have x plus 1 times negative x squared plus 1 has to be equal to 0. And then if you notice here, we can see that one of our solutions will be negative 1. Okay, but then we're going to solve this negative x squared plus 1. It looks a little bit odd because typically when we solve this, we like having a positive x squared. So we can actually factor that out. So we're going to factor out the negative 1, and that's going to flip these two signs on the inside to become x squared minus 1 equal to 0. And if we bring the negative 1 out front, we now have negative x plus 1 times x squared minus 1 is equal to 0. That's the difference of squares. And we have final solutions of negative x plus 1 times x plus 1 times x minus 1. We have two of those x plus 1s. So this will be x plus 1 squared times x minus 1 is equal to 0. And we don't care about order, but we do know that x plus 1 order 2 or multiplicity 2, so x equals negative 1 will be a solution, and x equals positive 1 will also be a solution. So we have two solutions there. That means we end up having a bounce at x equals negative 1. Okay. For f, we have 3x cubed minus 3x squared minus 18x. So right off the bat, I noticed that we can common factor by a factor of 3x. And so if we do that, 3x, and if we take 3x cubed divided by 3x, we end up with x squared. Negative 3x squared divided by 3x is negative x. And 3x divided by negative 18x will be negative 6. Has to be equal to 0. We can factor this quadratic, x squared plus x to the power of 2 minus x minus 6. What two numbers multiply to make negative 6 and add to make negative 1? Those numbers are going to be negative 3 and positive 2. So we have 3x outside of x minus 3 on x minus 2 has to be equal to 0. And therefore, x is equal to 0, 3, and negative 2. Or if we want to be polite, we can write these in order, negative 2, 3, and 0. So you can very easily common factor that to ensure that this works. Because remember, common factoring is a reasonable solution. You could use the long division. It's just that at some point, you'll end up having a factor of x to worry about. So always look for common factoring. So for g, if we have 4x to the power of 3 minus 20x squared minus 56x, we appear to have a common factor of 4x. So if we take 4x out of this, 4x goes into 4x cubed, x squared times 4x goes into negative 20x squared, negative 5x times, and 4x goes into 56, 15, 14 times is equal to 0. So what numbers multiply to make negative 14 and add to make negative 5? So it'll be 4x times x minus 7 times x plus 2 equals 0. Therefore, x will be equal to negative 2, 0, and 7 as our solutions. So when you set each of the three factors equal to 0, those will be our corresponding answers. Okay, well, let's continue on. Just checking to see where we are for time purposes. Okay, question 3. We're dealing with families of polynomials. So we want to write, and this is a very unusual math term, an equation, and meaning any equation for a polynomial with the following roots. So it has to have roots of negative 4, 3, and 5. And so when we write this as a polynomial, we have f of x is equal to k times x plus 4 times x minus 3 times x minus 5. So since we need an equation, means k can equal anything except k cannot equal 0. So so here we have an infinite number of solutions such that they will infinite number of k values that will satisfy the solution. So k could be 1, 2, 3, 4, whatever. So you could have, the most common one is, you could say that f of x is equal to x plus 4 times x minus 3 times x minus 5. That's a solution. Or you could have f of x is equal to 100 times x plus 4 times x times x minus 3 times x minus 5. That'll also work. So you can have k be anything you want except not 0. Because if k equals to 0, that means you've got a constant. Okay, so for b then, we have to have negative 3, multiplicity 2, 4, and 10. Okay, so multiplicity 2, so we could have, say, f of x is equal to x plus 3 squared, because it's got to be multiplicity 2, times x minus 4 times x minus 10. And that's an solution, or an equation, I should say, that is a graph that does this. You could put anything you want for k. So k can be so k is an element of all real numbers, just k cannot equal 0. So, but you just have to choose a specific value. So you might say k equals 1, and that's good enough for us. Okay. So let us continue on. Small application question. The product of 3 consecutive integers is 60. Find the integers. So if they're consecutive, the product of the squares of three consecutive integers is 60. Find the integers. Ooh. Don't think we have quite have time for this one. So we're going to leave that one for now. And we'll come back to it if we have time. Okay, so we're going to consider the following. X to the power of 4 minus 4x squared plus 3 is equal to 0. So if you notice here, this seems suspiciously close to, say, u to the power of 2 minus 4u plus 3 is equal to 0. Because we know in this case that if we were to solve this, we need to find two numbers that multiply to make 3, but then add to make negative 4. Those numbers would be negative 1 and negative 3. So this would be u minus 1. U minus 3 is equal to 0. And so you could say then that u is equal to 1 and 3. Well, this is pretty close to that. Could we just, perhaps we could make perhaps we could just try to work with this as if it was a quadratic. Could we find numbers that, could this be factored the same way? Well, we think it's going to be 1 and 3, right? And so what if we were to try to make this x squared minus 1, x squared minus 3 is equal to 0? Does this still end up working out? Well, if we were to FOIL this out, x squared times x is x to the power of 4. X squared times negative 3 is negative 3x squared. Negative 1 times x squared is negative x squared. Negative 1 times negative 3 is positive 3, which is equal to 0. And so we can see, oh, this does work. So we'd have x to the power of 4 minus 4x squared plus 3 is equal to 0. So we can factor this as a quadratic, right? And we end up, in this case, with two difference of squares. And so we could then take x squared minus 1 and make it x minus 1, x plus 1, and then this x squared minus 3 would say is x minus the square root of 3, and x plus the square root of 3 all has to be equal to 0. That would work. Okay. All right. Last example here. We're going to solve for k and roots. So x minus 5 is a factor of this thing. Determine the value of k. Afterwards, determine the other roots. Okay. So here, if this is a factor, so if we have f of x is equal to this x to the power of 4 plus kx squared plus 225, we know f of 5 will be equal to 0. So 0 would be equal to 5 to the power of 4 plus k times 5 squared plus 225. 5 to the power of 4 is 625 plus 25k plus 225. 625 plus 225 is going to be 850 plus 25k. Move the 850 over. We end up having 25k is equal to negative 850. So k will be equal to whatever negative 850 divided by 25 is. So k equals negative 34. So therefore, f of x will be equal to x to the power of 4 minus 34x squared plus 225. And so from here, you would just continue on to go ahead and solve that because we are out of time and we're going to be moving on to a new unit. I'll go ahead and complete up this part of the answer in the notes for you. But for now, thank you everyone for following along. Tomorrow is Truth and Reconciliation, so there's not going to be a class for tomorrow. So I will see all of you on Wednesday. Goodbye for now.